So when we look at this syllabus, right? Um, Obviously the syllabus itself gives us a very clear outline of what we're going for, but it can be a little bit overwhelming because we've dealt with syllabi before, and I mean it feels a little bit detached, right? So I want to just quickly work through it. So we've got three learning outcomes. You see that we've got AO1, AO2, and AO3. So
Yeah.
that's an assessment objective. So these are the goals that they have when they're assessing you. So we're looking, AO1 is knowledge and understanding. So we're looking for the definitions, facts, equations, and terminology. So these are, AO1 is basically your grammar, right?
Yeah.
I just want to check something here. Yeah. Okay. So AO1 is basically your grammar. Okay. AO2 is your application. So how can you use the knowledge you've found and apply it in unfamiliar context? So all the things that you've been learning, can you apply it in different situations, right? And that's where the application part of it all comes in. Then AO3 is your experimentation and stuff like that. And the point of experiments is to analyze and evaluate. So that's really just your rhetoric. Okay. So we're looking at the explaining mechanisms, interpreting data, justifying conclusions, and stuff like that. Okay. So we need to be structuring our thinking in the correct way. Okay. So what we're going to do is, instead of focusing just on AO2 and AO3, we need to plan backwards from AO2 and AO3. Okay. So we need to get that base grammar in place. Okay. So the grammar that we're looking at is chemical symbols, formulae, units, equations, state symbols, apparatus diagrams, terms like oxidation, electrolysis, enthalpy. Now, often what happens, like I experience it with Mathan a lot. So he'll do an experiment and he won't quite know what happens, and then he'll forget the experiment. He won't quite know what to call the things. But then later on, like today, while he was making tea, he was explaining condensation to me. Okay. And because he's now got the word for condensation, he was able to explain the condensation to me, explain the atmospheric pressure and atmospheric temperature, and then he was able to apply it in different situations. Like, say, okay, well, if we can find a way to create a constant heat source, then we could have a purification system for water based on condensation. Um, and like, if I'm honest, that sounds like a little OT. Right?
Yeah, I think that's all. Especially before, I just write this happened this, but I wouldn't really have a name for everything. Yeah.
So we shouldn't be doing too much of the equations and stuff before we know the terminology, but also, like, before we start writing the equations, we need to be actually observing the color change, the gas evolution, the temperature change. We need to be handling real or simulated apparatus. And so it's not always doable to be handling real apparatus, but before you write, there is a chemistry workshop that I want you to go to, I'll give you mom the details. But to actually do the practical stuff so that you see it in real life, right?
Yeah.
But even when we go to like Cybono and stuff, we see these color changes, gas evolution, temperature changes. We see them work through the stuff. Okay. Then after we figured out our grammar, then we can move on to why reactions behave as they do. So we're looking at cause and effect. So this is where we're looking at rate, yield, equilibrium. We're looking at conservation. We're looking at proportional reasoning. So what happens if we double the concentration, the pressure, the volume? And these we can do mathematically. We can do them through experimentation, but we can also do them mathematically. And when we do it, it's basically just playing around with our curiosity, right? Which is very on brand for you. Now,
Yes.
I think part of the issue currently is that you don't actually know what is expected of you. So, how much work is expected? What are you expected to be doing in all your free time? Um, and so I'm going through the syllabus so that we understand what's expected. Okay.
Yeah.
So now you could even use some kitchen chemistry here, but the whole idea is for you to start to explain the outcomes in your logic. Okay. Now you already do this. Okay. But it's so easy for chemistry, and this is what happened with me in high school. Chemistry became this disconnected set of facts. And while I understood physics, because I wasn't really working with the chemicals as much, it became almost a little bit theoretical to me, right?
Yeah.
Um,
Okay.
and so then our logic naturally like collapses. Okay.
Yeah.
Now with rhetoric, um, the examiners. So we're looking with rhetoric. We're looking at explaining chemistry clearly. So can we explain what's happening? Now the examiners are not marking vibes like it vibes
Yeah.
like this. They're marking for clarity. So you need to be able to explain all the mechanisms in words. By the way, remember that thing I did where you put the point on the wall?
Yes.
I now know why it happened, how to make it happen. And I will do that with
How?
you when turns around.
Okay.
But we're looking at writing clear methods. We're looking at interpreting graphs and tables. We're looking at justifying conclusions with evidence. And we're basically seeing, do you own it? Is it yours? Okay.
Really similar to like English analysis.
Yeah, you get it.
Yeah.
Just give me a sec. Okay. So I've got a bunch of curiosity questions which I can send you. But basically, by the end of the course, you should be able to answer all of the curiosity questions. Now, for each of these curiosity questions, I do have an experiment that goes with it, and some calculations and some explanation tasks. Now, like I said with the rhetoric, you need to be able to prove that it's yours. So you need to be able to basically write a paper explaining each of these things. So I'm going to be expecting you to do one pages. Okay, do you know what a one pager is? You know what a one-pager is?
Is it like trying to condense your point into one page?
Yeah, basically, you create a one-page. You can even make an infographic if to basically explain it to anyone.
Yeah.
So take all the information and explain it, and then you can even test it out on your brother. Honestly, you can give it to him and say, "Hey, does this make sense?" And then he's going to feel like he gets to tell OT what to do for once in his life.
Yeah. Yeah, that'd be fun for him.
So, like here, the explanation task here is explain why mass stays constant during state changes. So that is your one pager, right?
Yeah.
So I quite like the idea of it. I think it sounds really fun to do it like that.
Yeah.
But then we've got, on the other side, we've got Save My Exams, and we're working through the questions because we need to be experimenting and stuff like that, but we also need to be doing mixed examples. Okay? So I'm going to do a lot more mixed examples with you. But do you see in the subject content here on page 12? Page 12. Okay. So you see how it says state the distinguishing properties of solids, liquids, and gases?
Yes. Yeah.
I want you either in your member vault, or you can do it on little cards that you label correctly. I want you to actually do each of these statements. So when we go through a topic, like we've done states of matter is done for us, right?
Yeah.
So I want you see how it's got 6 things under solids, liquids, and gases, and 2 things under diffusion. I want you to create a little note that says state the distinguishing properties of solids, liquids, and gases. And then I want you to actually create a note or a one pager, whatever you want to call it, and do that. Explain it. Give it a good explanation. You can link out from it. But this is the core. If you can build this, you will do really well in chemistry. Because what this does is it forces you not only to do the questions and whatever, but it forces you to explain it. And when you can explain it, it means you
Understand.
it. Yes. By the way, you must see how large Riley. Riley, come sit hello. Riley, come. Jump up here. Go up. Up. Riley, up. Just come say hello. Look how big he's gotten.
Oh my god. The size of your torso. He's still cute. Like adorable.
Oh god. Oh, Riley. Sorry, baby. Sorry for waking you. Go back to sleep. Yeah. Right. Boy. Okay. So, how cute is he though?
He's adorable. He hasn't like lost a little bit of his cuteness. He kept it through.
So basically, as we go through a section in Save My Exams, I want you to be going through these things, and this is what you're expected to do. So at any point, if we have finished the section, and I say at any point, hey, send me your notes on solids, liquids, and gases, I should have at least 6 complete notes.
Yeah.
Complete one pager for solids, liquids, and gases. Because there's 1, 2, 3, 4. So ideally it would take more than that. You'd be building it out a little bit more. Okay.
Yeah.
So this is what I want us to do today. We're actually going to create these notes for solids, liquids, and gases. I'm going to go get my stuff. You're going to work on your stuff. I'm going to sit here and I'm going to do the same thing. And I'm going to add these to my Zettelkasten because, like, it's fun. Okay? And we can chat about it. And as we get stuck, but I'm going to, as I finish a note, I'll show you my note. You show me your note.
Okay.
Okay. You'll notice that my note is going to be less of a one-pager and more of a thing that, like, links out because that's just how I think. So I will have quite a few more than 6. But yes. So today we're going to do states of matter. So we're going to do solids, liquids, and gases, and diffusion, and just basically it's almost like a revision session, but a little bit deeper than that. Okay.
Yeah.